Hi everyone, today we are going to discuss about the quick sort algorithm. Quick sort is one of the different sorting algorithm which is based on the concept of divide and conquer. In this divide and conquer method, it will solve the problem into some sub-problems and conquer, that is, sub-problem by calling recursively until sub-problem solved and combine the solved sub-problems. There are different algorithms that follows divide and conquer method. One of the algorithm is quicksort algorithm. In quicksort, all heavy lifting or huge arrays sorting is done by dividing the array into subarrays. And the unique thing that is for quicksort, it will work by selecting a pivot element from the array and partitioning the other elements into subarray according to whether they are lesser than or greater than the pivot. For this reason, it is sometimes called partition exchange sort. At each iteration, we need to choose one element as pivot element, and the task is to bring the pivot element to its correct position. We can select any element as pivot. You can either choose a first element as pivot and the last element as pivot element, and also the random element as pivot element, or you can say the median element as pivot. There are many techniques to choose pivot element. Here in this video, I am going to choose the last element as pivot or the rightmost element as pivot element. Let's discuss the base idea behind the quicksort algorithm. Okay, let us check an example. This is an unsorted array. You can see an unsorted array with index from 0 to 7. So the total elements are 8. So the basic idea behind this quicksort, in this example, we are going to choose one element, key element, or we can say pivot element. So as I already mentioned, I am choosing the last element or rightmost element as pivot element. So the pivot element is 17. And we also discussed the quicksort algorithm is based on divide and conquer method. So this complete array will divide into subarrays. So the dividing of subarray is known as partitioning. So the partitioning method is the backbone of the quicksort. So we are going to partition the array in a way such that all the elements less than this pivot element, that is 17, would be to the left side of the pivot element, and all the element greater than the pivot element would be to the right side of the pivot element. And also if the element is equal to pivot element, that element can go either way, to right or left. It depends how you are going to implement the logic. Okay. Now we divided the subarray into two subarray, or partition the subarray into two. The left is one partition and the right is the second partition. In partition 1, all the values in the left side would less than the pivot element, and also in the right side all the values to the right side of this element would be the greater than pivot element. And so now we have found the correct place for one element. This is the correct place for pivot element. So we need to perform the operation to the left and right. So 17 is in the correct position. But we cannot say that the subarray values are in sorted order. But we can sure that the elements are lesser than pivot in the left side and the greater than pivot in the right side. But we cannot guarantee both subarrays are sorted. So we are going to do some operation to each subarray. First, we are taking left subarray. We can see the left subarray. Again, we are taking an element as pivot element. I already said that always taking rightmost element as pivot. So the pivot element is 4. So when we are partitioning again the subarray, so there will be nothing to the left of the pivot because no element is lesser than 4 and the element that is greater than 4 is in the right side of the pivot point. So the 12 and 15 and in the right side of 4. So we found the 4 is in the correct position. If we perform again the same operation to the subarray, that means 12 and 15, it remains same because the left subarray is now sorted. So the values are 4, 12, 15 and then also 17. So the half of the array is sorted. Then next we are applying this operation to the right subarray. So these are the right subarray. Again we are taking the rightmost element as pivot. So we will choose 30 as pivot. When we are again partitioning, so all the elements are less than the pivot element. So it will remain the same. And that we found the correct position of 30. And repeat the operation to the next subarray, that is 18, 20, 19. We can see the next subarray. We take 90 as pivot element and 21 is greater than 90. So it will move to the right of 19 and 18 will remain in the left because 18 is less than 19. So the 90 is in the correct position and there are only single element in both sides. So the right subarray is now sorted. So when we combine these subarrays, R can get the sorted array. So now we sorted an array using quick sort algorithm. This is the basic working of quick sort algorithm. Let's look at the algorithm and pseudocode. We are already discussed. First step is to make the rightmost element as pivot. And the next step, partition the array using pivot value. Then the left subarray partition recursively until sort the left subarray element. And then the right subarray partition recursively until sort the right subarray elements. Then when we look into pseudocode, first check the array elements are empty or not. by considering first element as left and the last element as right. If not, then the pivot will be the right element, that is the last element. And partitioning the element using partition function, that will partition the array using pivot values. Partition algorithm is shown in the right side. We are creating two variables, left pointer and the right pointer. Assigning the leftmost element and the rightmost element except pivot point to the two variable. Then first increment the left pointer by 1. After checking with the pivot value, if the left pointer element is lesser than pivot, then increment by 1. If greater than pivot, then the left pointer must stop in that position. Then it check with the greater right pointer. If right is greater than pivot, the right will decrease by 1. Or if less than pivot, then it will stop there and swap with the left pointer. Like that, the element which are lesser than pivot will come to the left side and the greater than will come to the right side by repeating the process. Let's check an example for partitioning the array. In this example, we are taking first element as pivot. So, the pivot is 7. We are taking first element as left and the last element as right. First, we have to find out proper place for this pivot element such that all the element lesser than pivot would be left and greater than pivot would be the right side. So first we are incrementing the left variable by 1 until we find the element that is greater than pivot. If greater than pivot, it will stop there. So now in this example, 7 is the first element and the pivot also same. So it is not greater than pivot, so increment left by 1. Then it is 6. 6 is also less than 7. So again increment the left by 1. The next increment, the value is 10. So it will stop there because the 10 is greater than 7. And check the right element. Right is 7. 7 is equal to 7. So it is not greater than, greater. So the right will stop there and then swap with the left element. That is 10 and 7. Now this is how the array look like. Then again check with 7. It is equal to pivot. So left plus plus. Then next is 5. It is also less than pivot. Again left plus plus. And the next is 9, which is greater than pivot. So left will stop there and right will check. First 10 is greater than pivot. So the right will decrement by 1. Then it is 50. 50 also greater than 7. So right minus minus. And next the value is 1. It is less than right. So right will stop there and swap with the left value. That is swap 9 and 1. and this is how the resultant array after swapping. Then next, increasing the left by 1 until the element is greater than pivot. Then it will reach 9. So stop there. Then right will move until get the element that is lesser than pivot. Then it will stop, reach 2. In this case, left is greater than right. So based on the index. So we will swap with the pivot element. That is swap 2 and 7. So now the pivot element is in the correct position and the left side of the pivot is lesser than the pivot and the right side is greater than pivot. So now we perform partition in the given array. So now we can perform this quicksort operation to calling same function to the left subarray and the right subarray, that is recursive function. So 7 is in the correct position and perform again this partition function to left and right. Then the resultant array is sorted. We can see in this image. So now we can go back to the algorithm and we perform the partition function. I'll show with an example. And again apply recursive function to the left and right until it will sort. That is quicksort function. We are performing again and again until it will sort. And the resultant array is the sorted array. This is how the quicksort works. When we analyzing the quicksort algorithm, the time complexity taken by quicksort is T of k plus T of n minus k minus 1 plus theta of n, where k is number of element which are smaller than pivot. As you might know that for some sorting or comparison based sorting algorithms, that best time complexity that is possible is n log n. Some of the algorithms that can provide this n log n complexity for sorting are merge sort and quicksort. So the time taken by quicksort maybe depends upon the input array and partition strategy. When the partition process always pick greater or smaller element as pivot, then it will be the worst case of time complexity. And also when the array is already sorted in increasing or decreasing order, then also it is an worst case. And when partition process always picks the middle element as pivot, then it is the best case for perform quicksort algorithm. Now we are in the end of the topic. So we discussed about quicksort algorithm and the basic working of quicksort, and we discussed algorithm and pseudocode, and also partitioning function with example, and we discussed based on the analysis of quicksort algorithm. Hope you all understood. Thank you.